You've probably heard of the double slit experiment. That's the problem. When something becomes famous, it becomes comfortable. It gets repeated in documentaries, textbooks, YouTube videos. It gets smoothed out. The edges, the parts that should disturb you, get quietly removed to make room for wonder without discomfort. So let's remove the comfort instead. The original experiment used light as a wave. A beam passed through two slits and created an interference pattern on the other side, alternating bands of light and dark. Physicists in the 1800s saw this and concluded, light is a wave. Waves spread, overlap, interfere. The pattern made sense. That version is not what should bother you. What should bother you is what happens when you slow everything down. Physicists eventually repeated this experiment, firing one photon at a time. Not a beam, not a pulse. One photon. Then they waited. Then another. Each photon hit the detector as a single point. Exactly what a particle does. But after thousands of dots accumulated, fired one by one, each with no knowledge of the last, the same interference pattern emerged. Slowly. Precisely. Inevitably. No wave. No beam. No interaction between particles. One photon alone somehow produced a result that requires two paths. You cannot explain that with anything you were taught before this moment. Take a moment to understand what that pattern actually demands. Interference happens when two waves meet. One wave pushes up, another pushes down, they cancel. Both push up together, they amplify. The result is a rhythm. Peaks and troughs. Bright bands and dark bands. That's the pattern on the screen. Now ask the only question that matters. For interference to occur, two things must exist simultaneously, in the same space, at the same time, and interact. A single wave cannot interfere with nothing. A single ripple in a pond doesn't cancel itself. One thing cannot be in two places, traveling two paths, and meet itself on the other side. Except that is precisely what the data shows. Each photon leaves the source as a single event. It arrives at the detector as a single event, that at one location, one moment. But the pattern those dots build, slowly, over thousands of arrivals, is not random. It is not spread evenly. The photons avoid certain locations entirely. They cluster in precise bands. They behave as though something passed through both slits and interfered. But only one photon was traveling at any given time. There was nothing to interfere with. This is not a measurement problem. It is not a technology limitation. Physicists have tested this with electrons, atoms, and molecules. The pattern always appears. The interference is always precise. Something about a single particle moving through space produces a result that classical physics reserves exclusively for two overlapping waves. That's not a paradox waiting to be solved. That's the territory you are now entering. Richard Feynman didn't try to make this comfortable. He looked at the data, accepted it completely, and asked a different question. Not, how does the photon choose a path? But what if the question itself is wrong? What if a photon, between emission and detection, does not travel a single path at all? What if it travels every path? This is not a metaphor. This is not philosophical looseness. Feynman developed a precise mathematical framework, the path integral formulation, built entirely on this idea. Every possible route a photon could take between 2 points contributes to what actually happens. Not the most likely route. Not the shortest route. Every route. Including the ones that bend backwards. Including the ones that curve around obstacles. Including the ones that seem physically absurd. Each path carries a value, the kind of weight. And those weights combine. Some reinforcing, some canceling, until what remains is the probability of where the photon actually arrives. Think of it this way. You are standing in a city. You need to reach a destination. In classical physics, you take the fastest road. In Feynman's picture, you simultaneously go through every street, every alley, every impossible shortcut, and the city itself decides, through interference between all those routes, where you most likely end up. The double slit experiment is just that process made visible. Both slits are available paths. Both contribute. Their contributions overlap on the other side and interfere, producing exactly the pattern the detector records. Remove one slit, and one set of paths disappears. The interference vanishes. A simple spread appears instead. The photon didn't go through both slits because it's strange. It went through both slits because in the absence of a defined path, all paths are real. What collapses that into one outcome is not the slit, not the screen, not the distance traveled. That comes next. Physicists wanted to settle it. If the photon truly travels both paths, then place a detector at the slits. Watch which one it goes through. Catch it in the act. Confirm the strangeness once and for all. They did exactly that. The interference pattern disappeared. Not partially. Not weakened. Gone. Completely replaced by two simple bands, exactly what you'd expect from a particle choosing one slit or the other. The moment the experiment gained the ability to know which path the photon took, the photon began behaving as though it had always taken only one. The natural instinct is to blame the detector, to assume that measuring a photon disturbs it, nudges it, interacts with it physically, disrupts the delicate wave-like behavior. This is a comforting explanation. It keeps reality intact. It suggests that the interference pattern is still there underneath, and we're just too clumsy to observe it without breaking it. That explanation is wrong. Physicists designed experiments where the detection was gentle enough to cause no meaningful physical disturbance. They designed experiments where the choice to detect or not was made after the photon had already passed the slits. The result didn't change. The pattern still vanished the moment which path information existed, regardless of when that information was created, regardless of how softly it was gathered. It isn't the physical act of measuring that destroys the interference. It is the existence of information. When the universe contains, anywhere, in any form, encoded in any particle, the answer to which slit did it go through, the interference dies. Not because the photon was touched, because the ambiguity was resolved. The photon doesn't react to your detector. It reacts to the fact that a definite answer now exists. That distinction is not subtle. It restructures what measurement means. It restructures what reality means between the moment something happens and the moment something is known. This is where most explanations quietly retreat. They introduce the observer effect and then gesture vaguely toward consciousness. The human mind, the act of looking, the presence of a scientist in the room. It sounds profound. It is also precisely wrong. Consciousness has nothing to do with it. The detector at the slit doesn't need to be read by a human. It doesn't need to be connected to anything. It doesn't need to produce a result that anyone ever sees. If the detector simply interacts with the photon in a way that physically encodes which path information, if any particle, anywhere, in any corner of the universe, is altered differently depending on which slit the photon used, the interference pattern vanishes. The universe doesn't wait for you to look. It only requires that a difference exists. Think about what that means with precision. Two outcomes must be physically indistinguishable, not just unseen, not just unmeasured, but genuinely identical in every consequence, for interference to survive. The moment the two paths leave different fingerprints on reality, even fingerprints nobody will ever read, the ambiguity collapses. Physicists have tested this with layered precision. In quantum eraser experiments, which path information was encoded and then destroyed, erased before any human observed it. When the information was erased completely, the interference pattern returned. Not because a mind was satisfied, because the physical difference between the two paths was unmade. The pattern is not about what you know. It is about what the universe knows. And the universe knows something the moment any physical interaction makes the two possibilities distinguishable. Not a moment later. Not when a conscious being reviews the data. The moment the difference exists in the fabric of physical reality, in the spin of an electron, the vibration of an atom, anything, the photon commits. This removes the observer from the equation entirely, and replaces it with something far stranger. Information itself, not minds, not instruments, not intention, is what separates a world of possibilities from a world of facts. So ask the question directly. Between the moment a photon leaves its source and the moment it arrives at the detector, where is it? What is it doing? What path did it take? The honest answer is not we don't know. The honest answer is that those questions have no answers. Not because our instruments are insufficient, not because the photon is hiding something, but because physics itself, at its most precise, most tested, most mathematically rigorous, does not assign the photon a location, a path, or a history during that interval. This is not a gap in our knowledge. This is a feature of reality. The photon's position between emission and detection is not unknown. It is undefined. There is a difference. An unknown thing exists but escapes measurement. An undefined thing does not exist in that form yet. The photon is not secretly traveling one path while we fail to see it. It has no path. Path is a concept that only crystallizes at the moment of detection. Before that moment, what exists is a probability structure. A spread of potential outcomes, mathematically precise, physically real in its consequences, but not localizable in space. Not a particle moving through darkness. Not a wave rippling forward. Something that behaves like neither until the instant it must become one. Feynman's path integrals make this calculable. But calculable is not the same as visualizable. You cannot picture it. Not because you lack imagination, because the thing itself resists the kind of existence that pictures describe. Every mental image you reach for, a blurred particle, a spreading wave, a ghostly presence haunting both slits, is wrong. Not approximately wrong. Categorically wrong. Those images import the logic of everyday objects into a domain where that logic was never valid. The photon doesn't travel through both slits. It doesn't travel through one slit. It doesn't travel. Travel is something objects do through space across time. And between emission and detection, the photon is not that kind of thing. What it is, precisely, honestly, without decoration, is an open question that physics answers only with mathematics, and mathematics answers only with probability. Richard Feynman said something that is easy to misread. He said nobody understands quantum mechanics. People hear that and feel reassured. Even the great physicist was humble. Even the man who built the path integral formulation, who calculated with inhuman precision, who won the Nobel Prize for his work on quantum electrodynamics, even he threw up his hands. That is not what he meant. Feynman was not being humble. He was being precise. There is a version of understanding that means you can calculate, predict, and verify. Quantum mechanics delivers that version completely. Its predictions are the most accurate in the history of science. Not approximately accurate. Accurate to more decimal places than any other theory humans have ever constructed. Feynman could do all of that. What he could not do, what nobody can do, is translate quantum mechanics into the kind of understanding where you close your eyes and see it happening. The kind where reality assembles itself into a coherent picture that your intuition can inhabit. That version of understanding does not exist for quantum mechanics. Not because we haven't tried. Because the theory itself suggests that reality at this scale simply does not work the way minds built for survival in a classical world are equipped to perceive. The double slit experiment is not a puzzle with a hidden solution. It is a window. And what it shows you is not a strange corner of physics that experts will eventually explain away. It shows you the actual texture of reality beneath the level where your intuitions were formed. A level where particles have no paths, where information shapes outcomes, where the past is not defined until the present forces it to be. You did not come away from this understanding quantum mechanics. Neither did Feynman. What you came away with is something rarer, the precise location of the boundary where human intuition ends and reality continues without it. That boundary is not a failure. It is the most honest thing physics has ever shown us.